Okay, guys, so let's start with today's session. Okay, so as you all know, Java. Okay, first of all, let's see what we have done yesterday. Maybe some of you have missed. So, what did we do yesterday? Okay, we saw some of the JavaScript functions. Uh, okay, so yesterday we saw recursion, closure, new function, arrow function, raised parameter, spread operator, global object, function object, and all those things. So you can find this file in the discussion group. I sent it yesterday, and after all this, we did some we did a drawing canvas using the canvas using the canvas. Sorry, not API. Using the canvas concept in JavaScript. So in this canvas, you can draw like paint. You can even change colors. You can add new colors. And the task that was given to you all was to add a tool to increase or decrease the brush size and an eraser. So have any of you done that? Reply with yes or no. Have you tried? Okay, Gaurav is done. So Gaurav, if you can send it to me now, I'll check it live.
কোড সেট করব না শেয়ার করব স্ক্রিন
Screen share ka? Okay, wait, let me stop it. Okay. Start.
এসছে
Okay.
তো বেসিক
Okay. Nice. Very nice. Okay. And eraser. Okay. Acha, now show me the code a little. Okay, you can change the thickness of the brush eraser as well. That's very nice.
কোড এই তো কই গেল
Just show me the changed part.
this is for thickness
Okay. Line with you have done with T and the T value you are getting from the slider.
yep
Okay. Okay, got
slider
it.
side is thick
Eraser.
and eraser I have
For
just
eraser, you
made
have just
another
added
element
another
in here
color. Okay.
and
And the
then
eraser color is equals to the background color.
yep
Okay. Okay. So, guys, you can see if you want to do it, and if you're not being able to, you can take help from Gaurav or me. So, okay, Gaurav, I'll give you another small task in here. You can add that shapes, how to add shapes. Yesterday, I saw you, I showed you how to add rectangles and triangles, right? So you do one thing, just like in Paint, there are option to add specific shapes. You do that, okay? Means
Achha,
you
okay.
can make when you click on the shape, there will be an option to increase or decrease the width and height. Okay,
Okay.
that would be a little bit of advanced thing for you. So it will be good practice.
Okay.
Okay, you can stop the presentation now. Okay. Okay, guys. So today we are going to see the how to make the game of Tetris in JavaScript. Okay, so let's see. So to make a game, first of all, we need to understand how means the game works. It means the game concept works. Okay, so first of all, before getting into the code, let's get into means let's learn about the game. Okay, so okay, so uh, okay, so here I have drawn the game. Okay, so here we in Tetris we have two means we have two main areas. First of all is the main arena where the actual pieces fall and where you where the lines collide. Okay, is it clear? Is video clear? Okay. Yeah. Hello. Okay. So in Tetris we have two not very clear, but it will do. Okay. Uh, it is actually drawn with pencil, so the color because of the colors it is not getting so clear. So in Tetris we have two main areas. First of all is the main area where the pieces actually fall. Okay. So if we are like if we are playing the game, the pieces would be like here. Okay. Let's say this was the L piece. Okay. So like this, the pieces would fall and it will fall. Okay. In the grid, it will keep shifting one by one. Okay. And if we press the means downwards button, it will fall faster. Okay. And then the logic that when it hits the okay in the line of rotation where left it. Okay. So if this falls like this, it would be means like in this position. But if we rotated it, then it would be like this means whichever position we rotated it to last, that it will stay in that. So now what happens is when you put one piece, then again another piece comes down. Let's say a T piece. Uh, let's say this piece comes down, then this will sit on top of this like right. It will sit on top of it like this. Okay. So when you drop the then again let's say a square piece comes or O piece comes. This is called the O piece. Yeah, we are drawing. I'm drawing the tetromino. Okay, then it will sit over here. This is the concept that is the pieces fall and they get into the empty slot. And when you fill all the lines in a particular line, that line collapses or vanishes, and you get a score. Okay, so yeah, Gaurav rejoin. Try others can see. I think your network has some problems. So that is the main arena. Now the main arena has 10 columns, and uh, originally it had 20 rows, but later 4 extra rows were added. That was because the means when the pillar got really high, the pieces had problem to rotate. Means if you start from here, you will only get the space to like till here up to 16, because the piece means the longest piece is up to 4 rows. So obviously as soon as it comes down, it will settle down. You will not get the chance to rotate. That's why 4 extra rows were added. Okay, so that's it. That's about the main arena. Now we have another sub arena, which is to display means the next piece that is going to fall. Okay, this is also very important because if this is not there, means it will be quite difficult to play the game. Yeah, let's say the L piece is the next piece. So here we will be shown the L piece. Then as soon as the L piece moves into here, okay, LPs moves to the main arena. This will again change to the next one. For example, the J piece is the next one, so it will change to J instead of the L piece. Okay, okay. Now the pieces. So we have a total of 7 in Tetris. We call the pieces tetrominos. Okay, so we have a total of 7 pieces. So this is the I piece. Then we have the J piece. Then the L piece. Then O piece. T, the S, and the Z piece. If the flashlight is on, actually, the pens it has been drawn with pencil. That's why it's being shown like that. Sorry, Siddharth. I'll send this picture later. Okay, I'll send it in WhatsApp. You can see it clearly then. For now, just understand what I'm trying to say. So now what I remember, rotate, right? So when means when something rotates, there needs to be a pivot or pivot from where it will rotate. For example, if a fan is rotating, so the pivot is the central point. So the fan rotates like the blades are here. Okay, so the fan will rotate through this point. Uh, so in these pieces, the pivots are different in all the pieces. Okay, so in the I piece, it is here. So let me show in another page. Yeah, see. So in I, the pivot can rotate this. Okay, this same piece over here, and this piece here. This important to follow because if you don't follow this, I mean same in pieces, it will be means very hard to code it. Okay, so that is same for all the pieces. Over here, see, the L piece has the pivot over here. Over here, so when it rotates, these two pieces go up. This goes down. Okay, so like this. Okay, now. Uh, Now we have the issue with colors. If all the tetrominos were of same color, means it would look very means plain and simple, and also it would means be very confusing when a line is being means when a line will collapse. Means we won't be able to understand that a line has collapsed. Okay, so all the tetrominos are colored in a different color. Okay, so means you can take any color, but if you go by the standards of the classic Tetris, so it is red, purple, white, blue, green, cyan, and yellow. Okay, now the colors can be haphazard, whatever color you want. It doesn't matter. Just don't give the means color the background color is, or else it will be transparent. Okay, so that's it about the concept. Okay, now I'll send this in the WhatsApp later. Don't worry. Now let's get to the code. Okay, so there are two ways to create Tetris in JavaScript. First of all, there is using the JavaScript's DOM manipulation properties. Okay, so as you all know, in JavaScript is means very highly capable in DOM manipulation and DOM tree manipulation. So we can use that. Okay, and there is again the second function, the one we saw the basics of yesterday. That is the canvas concept. Now the canvas concept is a little bit complicated. Means for you guys right now, and it is quite means long also. So today we are going to see using the DOM manipulation concept. Okay, so first of all, the main grid had 20 means 10 columns into 24 rows. So that is about 240 240 cells, right, in the grid. So we need 240 divs. Every single cell will be declared as a div. Okay, so we need 240 divs. So you must be thinking how means how to write so many divs one by one. So it is very simple actually. If you are writing in VS Code, the technique is simply write like this: div into 240. Sorry, dot I think I am forgetting the emit function.
না না ওটা করে একবার কন্ট্রোল স্পেস মারো তাহলে আসবে।
Look,
আবার কন্ট্রোল
না
স্পেস
না
মারো।
I think না না এক সেকেন্ড I think the emit function আমি কিছু ভুল করছি, wait. Okay,
100 লিমিট আই গেস।
yeah, I
100
think
করলে
লিমিটটার জন্যই হচ্ছে।
আমি
Okay,
101 করে দেখলাম এলো না, 100 এ এসছে।
okay, so লিমিটটার জন্য হচ্ছে না, রাইট? আমার মনে হয় আমি ভিতরে করেছি, এটা অনেক অনেক আগে করেছি। I don't even remember the whole thing yet, অনেক পুরনো এটা। So okay, so you can do it like 100 and 100 and then 40. So div into 100. Okay, so you'll see 100 divs will appear. It is pretty easy to write so many divs at a single time. Okay, so 100, so 200. Now div into 40. Okay, so all these are called emit functions. Okay, so all these means you can write so many codes at once. You can even declare a means div just by the class name. Okay, so, many of you know that, but is some of you who don't know, it is for them. So if for example I want to declare a div called main class. Okay, so dot main class and enter. See, the div will be formed. Okay, and if I want to with an ID, okay, to declare a div with an ID. So for that, it will be hash, then the ID name, and enter. You can also do both at the same time, like okay, the class and the ID both will be declared at the same time. These are emit functions. There's a cheat sheet available. You can go through that. Okay, there will be lots of emit functions to write your code easily. Okay, see, there are lots of functions. I'll send this as well if anyone wants to learn this. Okay, you don't actually need to learn this. Just please keep this as a reference when you are writing long code. That would be it. Okay, now let's get to the code. So after we have written 240 lines, so that would be our main grid. Okay, so that would be 10 columns and 24 rows. Now we need to declare one line that would be the line that is collapsed, means when all the rows are filled, that line will be collapsed. So we declare 10 divs as filled, okay, the class as filled. Now what this will do is we will use this class to detect whether means now this line does not need, means this 10 cells need not to be in the last row only. Okay, it can be anywhere in the whole grid. This is only used to detect whether all the cells in a row are filled or not. If they are filled, then that row will be deleted and you will get a score of 10 points. Okay, now that is done. Now as we have seen the for the mini grid where the next tetromino is being shown, for that we would need uh, uh, 16 24, sorry, not 24, 16 columns. Okay, 4 into 4. So for that we will write for 16 columns within the class mini grid. Now if you don't want to do this, it's okay, means wouldn't affect your game at all. Okay, means you can create your game with only this one. This mini grid is to show what will come next. It would not affect in any way the main grid. Okay, so we have drawn the mini grid now. Now let's style it a little. So okay, so yeah, so first of all we style the mini grid. Okay, we give the width 200 and height 480 pixel. That is to define the height of the playing area. You can increase it to if you are playing it in mobile, for example, you can give it to like width 100 VW and height 100 VH, so that the whole screen can be your game area. So that's up to you, but this is very important. Display flex and flex wrap. Gaurav, you want to explain why it is important?
Display flex enables you to place all the divs side by side, since the default direction of flex is row. Okay, so it is arranged like a row in a table. What does
Yeah,
flex wrap do? Flex wrap is basically once you have reached the limit, the width of the table, it just transfers the next element to the next row. If you don't give the
yeah.
flex wrap, it basically just I mean, what do I call it? Overflows over the table and just is a one long line.
So what
So
flex wrap will do is, for example, you have this cell like this, okay, and we have declared the divs over here, okay. So if we don't have wrap, it will just keep on going, okay, like this. It will just decrease the width of these cells to fit in, okay. So if, for example, I have 100 divs and I have just space for 20, it will divide every div into 5. Okay, So all these divs will be unusable. But if we now if we give flex wrap, what will happen is as soon as these 20 cells are filled, the rest will go to the next one. Okay, it will wrap up just like text wrap. How many of you have used font wrap? Obviously everyone. So just like in font wrap, as soon as the width is filled, it will move to the next row. Okay, so this is if you are doing through the DOM manipulation technique, this is very important to give the flex wrap. Okay, then a background color can be anything you want, like white or black. Just avoid any of the color that is in the tetromino. Okay, okay, then we define the individual cells. Okay, so height is 20 pixels and width is 20 pixels. So we are defining that each cell is a square. Okay, so now see, if you see, we have defined the height over here. Height of the sorry, width of the main grid is 200 pixels. Okay, so and see, width of each single cell is 20 pixels. So we can only fit 10 cells in here. Okay, 20 divided by 10, sorry, 200 divided by 10 is 20. So that's why flex wrap is very important. If flex wrap is not there, it will just compress this width into this smaller width, like, 10 pixel or 8 pixel. Okay, now the mini grid. That's done with the main grid. Then the mini grid. In the mini grid also it is same thing. Okay, just in a smaller scale. So the width is small, height is small, and rest all the things are equal. Okay, display flex wrap. Then also same in the mini grid cells also, height and width 20 pixels. So no need to waste your time over there. It's basically the same thing, main grid and mini grid, just in a small scale. Okay, now let's move into the JS part. Now is the most crucial part. Okay, so first of all, okay, here if you see, we are waiting for the whole DOM content to load. Okay, so why is that? Because as there are so many divs in the game, we need the whole game to function. Means we need all the divs to for the whole game to function. Okay, so we have to wait till all the divs are loaded. So for that we have used the arrow function. Okay, to wait till the DOM content is loaded. So when the DOM content is loaded, what will happen is the all the cells or the main grid is stored inside a variable called grid. Okay, and every single cell is stored inside squares. Now all the as there are 240 squares, so we are storing all those cells inside an array. Okay, so the array will be like the array will be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like this, it will be there will be 240 rows. Okay, so it will be like huge array. Like in a matrix, there are 3 into 3 rows. So consider this as a matrix of 10 into 240 rows. Okay, then we have a score display. Obviously score is if we don't have a score, then it's useless to make a game. Okay, so there will be a score div, so that we are storing under the score display. Then we have the start button that will start the whole process. Then all the some of the things like width, next random timer id, these are we are storing them as variables for later to increment them. So we are storing some global variables over here. Okay, then the colors. As I told you, you can color the tetrominoes whichever color you want, but if you go by the standard rules, so these would be the colors. Okay, white, cyan, yellow, blue, red, green, and purple. After that is the amazing part, that is defining the tetrominos. Okay, now you have to understand this part a little bit properly. The J tetromino. Okay, so uh, okay, now the J tetromino is like, right. So let's divide this into a box of, okay, 4 into 4 is very rough. Sorry, I'm not so good with drawing with mouse. Uh, so we need to draw the J tetromino, right? So let's draw. First of all, let's see how it works. Okay, so first of all, 1. Okay, so 1 means, uh, if you start from here, yeah, if you start from here, so 0. Okay, first of all, let's see. Yeah, let's see with the eyepiece. So the eyepiece would be like here. Okay, this is the eyepiece. So this will be the 0. Okay, then this will be defined as, yeah, width plus 1. Okay, 0, width plus 1, width plus 2, width plus 3, width, 3, 2, and 1. Now 0, 1, 2, 3. So that will define which cells in the grid would be colored. Okay, now this is for one rotation. Okay, now we all know every tetromino has, means, not every tetromino, means the J tetromino, Z tetromino, S tetromino, they have like 4 rotations, right? So we will have to define, means where the which cells will be colored in every rotation. So like in T rotation, we'll have to color these rows. Okay, we'll have to color these rows. Okay, so that would be one rotation. Then we will have to color, let's say, this, so it will rotate like this. So we will have to color these rows. Okay, so like this we will have to define all the rotations. So here these are for the J to tetromino. Okay, now this you will, means you need to draw yourself. If you are creating a new tetromino, like, yeah, you can create new tetrominos, but that will not have like 4 cells. Like tetrominos have a limit of 4 cells. Whatever shape you want to create, you will have to create using 4 cells. Okay, so for new tetrominos, you will have to create like 5 with using 5 cells or 6 cells. Okay, so that could be a fun thing, but that is also, it will add more complexity to the game. So you can try doing that after learning. So like this, you can create your own pieces. Now there are many ways to create the tetrominos. Okay, here we have used the width property. Okay, you can also create using simple, means simple matrix. Like you can define like 0, 0, 1, 0, 0, 0, 1, 0, 0, 1, 1, 0, 0, 0, 0, 0. So that is the J tetromino. Okay, so that would be like the J tetromino. You can also create it using simple matrix. Okay, now for simple matrix there is one more step to do, that is to means this will be stored in an array. So it means every time you move the tetromino through the grid, the whole array would be moving. Okay, now that way we have created all the tetrominos. You can see that later, because if I try to show all of that to you right now, it will take a lot of time. Now, I means after doing all this, we can now test how our tetromino is means looking. Okay, so right now this would be the screen that we are getting. Okay, so this is the main grid. Okay, and this is the mini grid. So here there are 240 cells. To if you want to visualize it, then you can do that by okay by giving us small border to every single cell. Okay, okay, see, so that is all the means because the border is also taking some space. uh, if we decrease this by 19, okay, see, this is all the cells, okay, in the grid. Now we can keep the border color, but that would look like means specific types which we don't want. So that's why we will remove it later. Just to visualize it, we have given it now. So now the mini grid also has the same thing. Okay, for the mini grid also you can do. It's basically the same thing as I told you. Okay, here also you can see there are three columns and 4 rows. So 12. Okay, then okay, now let's get back to the JS. Okay, so now we have declared the Tetris. It means we have defined the Tetris, each individual Tetris. Okay, then we need to store the Tetris in an array. Okay, why? Because means these 7 Tetris will not actually come like we will get the J Tetris first, then we will get the I Tetris. It does not work like that. Means the Tetris comes, tetrominos come in random. Okay, you can get the J Tetris, then you can go the get the O Tetris, then the L Tetris. There is means it's nobody has ever means been able to say predict which Tetris will come next. Okay, so for that we need to store it inside an array. Okay, then the array, from the array we will get the random Tetris. Okay, so we are storing that inside a variable called random, math.store, math.random, and tetrominoes.length. So the tetrominoes.length is the length of the array. Okay, so it is simple getting a random element from an array. That is a simple thing. Okay, then there is the rotation. Now right now the current rotation is 0. Okay, if you remember, uh, okay, next random is also 0, right? So we will change that in the mini grid. Yeah, so this random is the piece that is actually means inside the main grid. So it would be the piece that will be falling over here. Okay, and this next random, okay, this piece would be the piece that would be here in the mini grid. Okay, So any doubts, anyone till now? Please ask. It can be a little complicated for some guys. Please ask. Anyone? Okay. So I don't see any doubts. So let's get to the next part. What is it? Okay. So so that's about how the Tetris will enter, means how we will get the tetrominos. Okay. Now now after this, the rest of the game is divided into modules. Okay. Now understand this again. Uh, if we divide the game into modules, first of all we will get the draw the. Let me get a notepad. Okay. So we will need a module to draw the tetrominos. Then we will need a module to rotate the tetromino. Then we would need a module to move the tetromino. Okay, so when the tetromino is falling, we also want to move it left and right. Okay, so then we need a module to stop the tetromino. There are many submodules inside this module. Move the tetromino. There would be a one to move the tetromino right, then there will be left, then to detect when you have hit the right wall and the left wall. Okay, then stop the tetromino is one module. Then fifth one would be to detect all columns filled, okay, in a row. Sixth one would be to detect uh, all rows in a column are filled. Now, why is this also important? Because this is how the game is declared as over. When any column touches the roof of the grid, that's when the game is finished. Okay. Then we need another module to add the score. Then we need a module to display the next tetromino in the mini grid. Then we need another module to declare game over, and another module to start the game. Okay, so if we divide the game into these sub modules, it would be quite easy. Like if you try to make the game as a whole in a single module, it will be very complicated. But if we divide it into sub modules, then it becomes very easy. Okay, so now let's see the next one. So the first one is drawing the tattoo. Okay, so for this we define a function draw. Then we for each we take the current position of the cell we are in, means the tetromino is on the cell. Okay, then we add the means class list dot add tetromino. Now from where are we getting this tetromino? We are getting that from the random. Okay, now this tetromino means adding this tetromino would mean drawing any one of this tetromino into the main grid. Okay, so when that piece is drawn, okay, so it means right now the piece would only be drawn. It won't be able to move or rotate or anything. Okay, so if we see right now, uh, the tetromino would be like over here, like J piece would be like stuck over here. It won't be able to move or do anything. We press the keys, it would not do anything. Okay, then there is the undraw tetromino. What is this used for? This would be used for when the tetromino has like is hit the bottom. Okay, and then all the rows have been filled, so it will be used for that, to undraw the tetromino. So this will not be used right now. It will be used later. This undraw means this draw and undraw is actually in the main grid. It is used. The undraw function is used later, but in the mini grid it is used every time. When we get the next tetromino, we draw the tetromino. Then when we get the means another tetromino, we undraw the last one. Okay, then we again draw the next tetromino. So in the mini grid, these two functions are very important, but in the main grid, this one will be rarely used. This one will be used a lot. Okay, now we have got the tetromino. Now we need to control it, like left, left, right, top, bottom. Okay, the top one is for rotate, and to move down faster, it is the move down key. Okay, then so for that, what we do is we use key codes. Like all the keys in our keyboard are stored. We have specific key codes that we can use to detect means which key has been pressed. Like for enter, it is I think 37 or something. Yeah, for enter it is 37 I think. Yeah, so like that, the left key, right key, top key, and the bottom key. All the key codes you can test whether that key has been pressed or not using their key code. Okay, then what you do is you simply add the controls to that. Okay, like when I press that left key, it moves left. When I press the top key, the tetromino will rotate in clockwise direction. When I press the right key, it will move right, and when I press the down key, it will move down. Okay, and then we again add a event listener for key up. Is to just like yesterday we detected when the mouse was being unclicked. In the same way, today we detect when we have stopped pressing the key. Okay, so then first means we need to define these functions, right? Move right, rotate, move left. Okay, so we start with move down. So move down, when the tetromino moves down by a cell, we need to undraw the tetromino from the means above cell. Okay. Mm, yeah. So when it shifts by one means when it shifts by one cell down, we need to undraw the tetromino from the above cell and then again draw it in the bottom cell. So first of all, what when we move down, what we do is first of all we undraw it, then we detect the current position. Okay, then we add one width. Okay, so that means we are adding one cell. Then we again draw the tetromino, then we freeze it. Okay, then we do the same thing again. Okay, we again undraw the tetromino, we get the current position, we add a one width, then we draw it, then we freeze it. Then we do that same thing again and again and again until it reaches the bottom point. Okay, now the freeze function. What does the freeze function do in this process? Okay, let's see. The freeze function. So what the freeze function will do is when you undraw it and then draw it, now there is a means you need to have a little bit of gap in that process. Okay, or else it will just fall like water. Yes, it will continuously keep falling. So you will not be able to means rotate it properly within that time. Okay, so means it would be very difficult to play the game. That's why the freeze is very important. Means to give that little bit of gap between the means falling of the pieces. So then what we do is we detect. Okay, uh, if the means if the all the rows are filled. Okay, so this freeze is for uh, this freeze is for when you hit the floor. It's after you have hit the floor. If the okay, while playing Tetris, there are some moments when all the 9 rows are filled. Sorry, all the 9 columns are filled. Just one cell is left, and we just keep waiting for the eyepiece to come. As soon as the eyepiece falls into place, the whole row vanishes. Right. So this thing is like that. Okay. So when the piece falls into that into the floor, it detects whether all the columns are filled or not. Okay. If if they are filled, then it will not hit that cell. It will sit above that. Okay. For example, I have some pieces in the last row. So this tetromino falls to the floor. It detects that the last row is filled. It will sit above that. So it will sit on the second last row. But if it is not filled, then what it will do is it will go to that last row, and it will add filled over there. Why? To declare that this cell has been taken by me. Now, if we don't do this, then the pieces will fall right through the floor of the board. Okay, so this is like means it is like a brick wall for the game. Okay, this piece will stop the rest of the pieces from falling down. Okay, as soon as that piece is closed, okay, then we declare that yes, we are done with this piece. Now we need another piece in the game. So then we call the random. Okay, and then we call next random. So then next random again calls another piece. Okay, from the tetromino array. So it will get like we got the J piece first. So then it will call the S piece. Okay, then that piece will become the current piece. Here, see, the determines random current rotation. Now that current position is let's say equals to 4. Okay, this has been defined by by randomly. Then we need to call again all those functions. Okay, like draw, display shape, add score, game over. Why are we calling these? The game is not over yet. Okay, and we don't know whether the score will be called or not. Means whether we will get score or not. Means, every piece falling into the floor doesn't mean we will get a score, right? Only we get score only when is mm, a row collapses or vanishes. But we need to call this function because we will verify that whether it is happening or not inside this function. Okay, that's why we are calling this function. Means as we remember yesterday we saw the callback function. We are doing that over here. We are using the callback function. Then we have seen the move down function over here, right? Now we will see the move left. Move left is pretty simple. We will just in the same way we shifted from one cell in the top to one cell in the bottom. We'll shift one cell in the right to one cell in the left. So here we first of all undraw. Then we detect whether we are at the edge of the board or not. If we are right over here, okay, if we are right over here, the piece will not be able to move even if when we click the left key. So we will need to detect whether we are hitting the left wall of the board or not. If we are not hitting, then it will be able to move left. If we are hitting, then it will freeze over there. So if it is not at the left edge, then then decrease the current position by 1. Okay, minus 1. Okay, we are decreasing. If it is not hitting the left edge, then shift 1 position left, and if it is hitting the position, no, sorry. uh okay, now over here we means we detected whether we are hitting the left wall or not. Okay, then we are hitting over here whether we have hit, whether if we have not hit the left wall, then move 1 position left. Now we also need to detect whether we are hitting another piece or not. Okay, I'll have to show you in diagram. Okay, let's say we have a piece like this, then we have a piece like this. Okay, then we have a piece like this. Now if I have a O piece, okay, the O piece will come over here. Right now we can move to the left. Okay, we can sit over on top of this. Okay, but if I don't move, it will come over here. Okay, now if we press the left key, it will detect that there is another piece, means the left cells are already filled. Okay, so it will not move left, it will just keep falling down. Okay, it will keep falling down, and then it will hit this piece over here, and it will stop over there. Now this is also important, because if we don't do this, then means the pieces will overlap. It will go over this piece, like it will sit like this. That would be like ridiculous. Like there is an O piece, and then the J piece comes, and we don't press it over here. Okay, so it will just sit over this like this. The game would be weird. So we detect whether it is hitting another tetromino or not. Okay, then we again draw it. Okay, after detecting all this, we again draw it to the left. If it is means if it is possible to draw, then we draw. Otherwise, we don't. Same thing with the left, with the right. Basically the same thing, just the variables are different. Okay, so move left and move right. It's same. Got it? Okay. Till up till now, it was means one particular portion of the game, that was means to get the tetromino, to get a random tetromino, and then how to make it fall, and how to move it left or right. Okay. Any questions till now? Okay. No questions. Now let's get into the rotation part. Now we will need to rotate the tetromino, right? But before that we need to we need two more functions to it means detect whether it is hitting a edge or not. Okay, so just simple two functions, return current dot sum. We have already done it over here, right? Like move left and move right, but that is for movement, means we have declared whether it is hitting the edge, so it won't be able to move. But here what we are doing is, when we have hit that an edge, here we are means we are detecting. Okay, so when we have hit an edge, it will just go down and sit over there. Hmm. So when the next piece comes, this piece becomes the edge for that piece. Like if I piece is sitting, means at the bottom of the right edge. When another piece tries to hit the eyepiece, it will act as an edge for the means another piece. Okay, so this it's easy simple functions. Okay, then we get into the rotation part. Now, to first of all, to means get into the rotation part, we need to detect which means which position the tetromino is already in. Okay, so uh, again we need to go back to the okay. So here, mm, okay. So if we are in this position, let's make- if we are in this position, we need to rotate to this position. Okay. So when we press the top button, we will rotate it to this position. So if we are already in this position, we rotate to this position. Okay. So detecting which position we are in is means important for the rotate to actually work. So means if we don't detect it, so we simply just rotate it. It was in this position, it will simply go to this position. If it was in this position, it will go to this position. It will be random. Means you will not be able to means fit the pieces properly into the right places. Okay. So we have means over here we check the position, rotated position. So it's about here. Okay, current position. Now current position equals to +1. So this is the reason we divided the tetrominos. Means while defining the tetrominos, we defined every single rotation of the tetromino. Okay, like every rotation is defined over here in a particular array. Okay, after that we get into the rotation part. So after we have, it means we have already detected which position it is rotated in, we need to rotate it to the next position, right? So here what we do is we undraw the tetromino first of all. It's means same like moving left, moving right, moving down. We first of all undraw it, then we means we get the current rotation, and we go to the next one. So let's say we are in this one right now. Okay, we are in this one, we undraw it, and then we go to this position. When we are this position, we undraw it and we go to this position. Yeah, so if you are means defining the tetrominoes, it is very important to define it in a serial order. Like you means I am defining it just like I drew it in the means in my paper. uh, Draw it in the serial order, then it will just move to the next piece. If it is in this piece, it will move to this piece. Okay, so that's how it is rotating. We are not rotating it like means we are not rotating the whole grid like 80 degree, 90 degree. No, we are simply moving to the next tetromino within that array. No, see this. I means I've added in this comment. Uh, why it is moving to the next piece? Because uh, we have indexed it like that. Okay. uh, okay, now the rotation is done. So that is all about the main grid for now. Okay, so now we need to means we can play the game exactly means with no problems right now. So if we just add the start button and add the score and the game over. Okay, Okay, we can play the game without any problem. We can rotate it. See, it will not hit the. Okay, that's the problem. I think there are some bugs in the code. I'll have to fix it. But okay. Okay. So it works without any problem. So means I would say the main part of our game is done. So what is left now is simply okay. I'll show you how the pieces will vanish. We haven't discussed that part yet, but I'll show you right here. Okay, I think there are some bugs in the code. Okay, so code is I think there are some bugs. Mm, okay, first of all, let's do the mini grid thing. Yeah, so the mini grid is similar thing, but with means some exceptions. Like we are displaying the shape in mini grid, but we are not rotating the shape. We are not moving the shape. We are simply just displaying it. Means we are drawing it and we are undrawing it. Okay, so now as we are not rotating the tetromino, we means we select a certain position, like like for the T position, we select like this position. Okay, like we want when it is in the mini grid, we want to show it in this position. So we just copy this code and then we paste it over here. We just add next width with the width. That is because means the width has already been used there, so we use another variable next width. But other than that, it is means exactly the same. Zero means if it was in the main grid, it would be zero width plus one width into two plus one. Okay, so the mini grid is just to show, means to display the data. It's nothing else. Okay, then here we have defined means which determinants will be shown. Okay, like we had one main grid, one array for the main grid. This is another array for the mini grid. Now we display the Tetris over here. Okay, so we display the shape. So we display square for each. We define which cells will be filled. Okay, and we change the background color with that particular Tetris's color. Then is the up next determinant. Okay, we as soon as this is done, okay, the square is filled. We wait for the main grid to means for a piece to fall to the bottom in the main grid. When it is done, we move to the next piece in the mini grid as well as in the main grid. Okay. Okay. Where was the bug? Okay. So now it's working. I think we were missing some code. Mm, Okay, so now if you see, we can play the game exactly like how it should be played. Okay. Uh, every piece works exactly like we want it to. Now see, if I hit right now, it won't go. Okay, that's because the edge is stopping it. Okay, I can go on. I have, I can score as much as I want because this is my game. I can simply edit this. No one would notice, but we won't be doing that today. Uh, well, that was today's session, but we are just going to see two things: the ad score. So for the ad score, uh, what we are doing is we are going through all the rows. Sorry, all the cells. So there are 240 cells. So we are going from 0 to 239. So that would be 240. So every time we are moving from one cell to another. Now uh, understand this thing. We are going from top to bottom, right? But why are we moving through the width? Gaurav, you want to explain that? I think you will be able to.
with দিয়ে যাচ্ছে ওই
হুম, আমরা ওপর থেকে নিচে যাচ্ছি,
হুম
ঠিক আছে, বাট আমরা উইডথে কেন আমরা ই করছি, উইডথে প্রোগ্রেস করছি কেন, হাইটে কেন করছি না?
ফ্লেক্স দেওয়া আছে বলে
Yep. এখানে actually we are just moving from this cell to this cell, but because we have given flex wrap, that cell is means has been brought to here. Okay, but that is just in the means position wise. It has not been brought like from, it has not been transferred from width to height. It is still in the same line. If we just undo the flex wrap thing, this line, okay, and we give border, okay, border, let's say red. Okay, see, it is being stopped by the main gate, but it just passed. Okay, so that means to now to draw some block from here to here. Now I told you now that it will divide the pieces into, means it will divide the divs into the width available. See, see how thin all the pieces are to accommodate all the 240 pieces. See, every single line over here is a piece, means is a div. So that's why flex wrap is very important. Okay, it is going till here, because even means the means compressed divs are not being able to be accommodated inside this div. So when we are drawing, let's say we are drawing a piece from here to here, we are not actually drawing the piece here. We are actually drawing the piece like one is here and the other is here. Okay, this piece goes down to here. Okay, then the next would be over here. That piece will go to here. Okay, so when we are drawing the piece, we will move through the width. Okay, now when we are doing it through the matrix way, we don't do it this way. Then we move through the height and width both. But here we will just move to the height width. Okay. Okay. Yeah. So we are going through all the cells from 0 to 240. Then we are going through one row. How? One row means 10 cells, right? So from I to I plus 9. So we after going through all the 10 cells, if every cell is filled, here we are checking if all the cells have have the filled class in them. That means one full row is means filled. Okay, obviously it means all if all the 10 cells are filled, then the full row is filled. So then we get a score of 10 and we display that score. Okay, then from for that row, what we do is we remove the field from all the cells. Okay, and we remove the tetromino that is on that means on the cells in that row. So if let me get it quickly. Now if this piece falls right into here, okay, so all the means all the pieces will be filled. Now that piece is vanished and all the tetrominos that were in the cells also vanishes. Okay, so we remove all the tetrominos. Okay, and how do we do that? We remove the color from the cell, so the color changes back to the background color. Okay, now the cells don't have any color. The main grid has, but the cells inside the main grid don't have any color. So we just simply make it means we don't give it any color. It becomes transparent, obviously. Then we need to do another thing. Okay, so we have removed the row. So then how is this going down? Means as soon as one row is finished, add score has been added, the next of the determinants above that row comes down, right? So how we do that is we remove that row from there and we add it to the top. Okay, so here we are removing that row. Okay, here we are squares dot splice. Now the splice function we saw yesterday. Okay, uh, const square removed squares dot splice. We take that row from took that row from there. Then what we do is we then again go back to the grid and then we append the child. Now obviously when you remove 10 cells from the grid will become of 230 cells. So 10 cells will be left at the last position. So when we append the child means append it back to the grid, it will obviously get added to the last. Okay, so if we don't just let's do one thing to show you. If I don't remove this tetromino or the background color, see, uh, see guys. So as I didn't remove the background colors, so we just removed it. We just kept the field, huh, and it went from here to here. So it was removed from this position, and then again it when it was appended, it went back to the top of means to the last position, that is here. So I hope you understood means this concept very clearly. Any doubts means till now? Come on, after so long, so many modules, you don't have any doubts. I don't believe that. Any doubt? Anyone? Okay, no doubt. Okay, so let's. hmm. So we have done that. Okay, so we have added this square cells back. Now all the only thing left would be uh, if we don't if we don't write this function, we can still play the game, no problem. The only problem would be the game would never end. Means even after it has reached the top, like if we reach the top, okay, now the game has ended, right? But if the we don't means define when the game would be over, it would just keep going and going like that. Okay, now let's test that. Oh, sorry, I think we will need to define it because we have called it other places. Okay, okay, see, the game will keep playing. Look at this mini grid. Okay, it will never end. You can just keep playing it means to infinity. Will not get any score or anything, but it will keep playing. So that's why it is very important to define how the game will end, or else all the fun will be gone. So when does the game end? So we, uh, now to detect how the game ends, uh, for the means to get a score, what we did was uh, we were checking whether all the cells in a row are filled or not. But to check whether the game is over or not, what we do is we check whether all the cells in a column is fixed or not. Means if all the cells like in this column, all the cells are filled, right? So as soon as it touches this, the game would be over. So we are checking for that. So how we are doing that is we go to the current position, okay, and then what we do is in the how we move through the row is we go to a particular row like I, then we go through I plus 1, I plus 2, I plus 3. This like if like we're here I plus 1, I plus 2, I plus 3, I plus 4, I plus 5, I plus 6, right? But in the how we move through the column is we go like I, okay, then 2I, 3I, 4I, 5I, 6I. So that is how we are moving through the rows to check every means every cell in the column. Then when all the piece means all the cells are filled, the score is we display instead of the score we display end, and we then again end the game and we clear the timer and the whole game comes to a stop, and that's how our game will stop and we will get a high score, or else it will never be a high score, it will just be means we will always be within the game. Okay, so that was today's session. uh, i hope I hope you all understood at least some of it. Now I'll wait. I'll just be here to get some questions. Any questions, anyone? Not just on today's session, like in general, like how to learn any particular topic, or if you are having issues on any project you are doing. Any questions? This is a boot camp. We are supposed to help, like, in all aspects of your learning. Any questions? Okay. So okay, so today's session is done with. Uh, okay. Okay, so you guys can now leave. Sorry, the session was a little bit long. That was because the topic was a little.